And welcome back everyone to the final video in our series on Introduction to Mastercam. And in this video we're going to be covering how to add a second group in here so that both the first operation and the second operation will be contained within the same Mastercam file. That makes it super convenient if you ever have to reopen a file or hand it over to some other programmer. They have everything they need within the same file. So to start off, we're going to actually simulate these toolpaths and save some stock as an STL file. So we'll go ahead and make sure everything is selected by clicking the machine group, and we'll simulate these toolpaths. We'll run through. And once we've got it simulated through, we'll go to Verify tab and Save Stock as STL. And we'll save this to our desktop. I'll call it Mastercam Titan 1M stock here. So we'll save that and I'll replace that. And you see down here it's working. It might take a second to save this as an STL. With more complex parts, it takes even longer, sometimes a few minutes or more. And the idea here is that we'll import this stock so that we can see exactly what remains to be cut. So now that our stock has been saved, we'll come back into Mastercam. And we've got our toolpaths here. And for the sake of organization, let's go ahead and collapse down our toolpaths. So our machine group here has all of the first operations. Now, I like to put second operations in a separate machine group altogether. So let's go ahead and right click and create a new machine group, and it'll be a mill group. And it brings up our stock setting here. And in our stock setup, we'll go ahead and import a file. So we can either set up stock here as a block, or we can import an STL file. So we'll click on File and Open, and we'll find our stock, which was saved to the desktop, Mastercam Titan 1M stock. Make sure it's displaying, and in the case of a file, I usually like to display this as a solid, and we'll click OK. So now you can see Mastercam has brought in the stock that we've cut and shows exactly what remains to be cut here. So that's a super handy tool. I use that quite a bit. Just makes seeing exactly what you're doing a little bit easier. So under our toolpath group, let's actually rename this up to as well. So right now, if I go to my view and my axes, I can see my gnomon is right up in the top here. Now, if I were to take my part and translate this and flip it around, much like we did at the very beginning, I could do that, but the problem there is all of the toolpaths that we've already created over here are going to end up needing to be regenerated because we flipped the model all around. So to prevent that from happening, what I like to do is to create a new plane altogether. So for the sake of visualization, I'll go ahead and turn off my stock so we can see a little clearer. Now we want to flip this over, and we want to put our gnomon in the top here in the center. So let's grab this. If we single left click, that'll bring up a gnomon that we can then place. And for the sake of ease here, I like to place this in the center, again, just like last time. And the easiest way to do this is to go up to our auto cursor and click face center, and that's going to anchor our gnomon to a face. So we'll click here, and you can see that we are anchored right to the middle at the very top. So let's call our plane up to plane. All right, so now in our planes manager, we'll click that and we can see all of these planes, and we'll see that our current active plane is actually the first plane, and that you can tell by the WCS, C, and T here. The work coordinate system, the construction plane, and the tool plane are all set for the top plane. So we want to set those for the op2 plane. So we'll select the plane and then we'll hit this equals button, and that's going to set that to be our active plane. Now you can see these gray lines that I've got showing, that is our master origin, and the greenish, reddish dotted line is our op2 plane. Alright, so now we're ready to go to start chaining our toolpaths, and we'll turn our stock back on. So right here we need to face this toolpath, face this part, and then we're going to come in and create a little chamfer around the outside edge. So let's go ahead and do a facing toolpath. So face, and again I could leave without chaining here, but I'll go ahead and chain this upper loop here. That's going to bring us into our facing toolpath dialog window. And because we created a new machine group, we no longer have any of our tools. So we'll need to select a tool. And here I'll go into the same library that you will all be using. Again, if you haven't had your tools filtered, you'll want to select the face mill. And we'll choose our 2-inch face mill here. And for a comment, we'll call this face to final height. In our cut parameters, again, we want to make sure not to leave any stock on those floors. All of this should be good. You just want to make sure you have zigzag and high-speed loops. Now, we do want to turn on our depth cuts because our carrier stock here that we've left over from our first op is about 1/4 of an inch, and theoretically this tool might be able to take 1/4 inch, but it's better to give it a little bit of a depth cut, as well as it's going to leave a slightly better finish. So for a rough step, let's put 0.1 inches. Now you could come in here and add a finish pass, and the finish step here, we'll call that 0.010 of an inch. So that's just going to leave an extra cut at the bottom of 0.01. That'll leave an even better surface finish. In our linking parameters, we want our depth to end at 0. Now mine automatically came in as top of stock 0.25 here. But you'll need to know the difference between the stock that's remaining and the top of the part, in this case because our initial stock was 1 inch and we cut down about 3/4 of an inch, we know that that is 1/4 of an inch. In some cases you might say cut a little higher if you're not totally certain if that's exactly 1/4 inch, or if some of the parts maybe they're a little thicker than others. So we'll leave that at 0.3 and we'll click OK. Now if we zoom in here, we can see our depth cuts. We see our first depth cut, our second depth cut, our third depth cut, and then that small finish pass there. So let's run through that on backplot. And we can see it's doing exactly what we want. And let's just go ahead and run it through our simulation here, verify. So we can now see our stock is our previous cut model. So let's play through. And with that yellow cut zone, we can see that we have in fact faced this off to the height. Great. So all we need to do now is create that little chamfer. Back in Toolpath, we'll do contour. Again, we want to be on chaining loop. You can leave face on. This allows you to select individual faces like this. Now when you do that though, it kind of creates a whole slew of issues, so I generally like to stay away from selecting faces because it just isn't super convenient many times. Sometimes there's an application for it, but for simple chaining like this, we want to avoid that, so I like to just turn off the facing option. So we'll click this chain here, and we'll note that we're going in a counterclockwise direction, and we're cutting the outside, so we do want to reverse that to be clockwise so that we can climb cut this. Let's click OK. In our tool, we need to then grab a chamfer mill again, and we've got it all pulled up here, but again, if you didn't have that pulled up, you can double click on chamfer mill. We'll choose our 1/2 inch. We'll call this toolpath chamfer the part. Cut parameters. This is where we're going to go ahead and change this to our 2D chamfer. Chamfer width, let's change it to 0.01 inches. Bottom offset we can just leave as the default. Again, making sure there's no stock left. No depth cuts needed here. Lead in and lead out, again, the defaults here will be fine. So yours will say 100% here, 100 there, and 90 here. So don't worry about those. Breakthrough we don't need. No multi-passes. And finally, our linking parameters. We can change our top of stock here to 0. And again, when you're chamfering, you always want to make sure that that depth is set to 0 because this right here is defining the depth and width of this 45-degree chamfer. So we'll OK that. Save. And we can then see our chamfering toolpath. Let's go ahead and run both of these through the simulator now. And we'll play through. Now we can see our part, and I don't like that chamfer, so I want to actually make it a little bit bigger to match the initial chamfer. So we'll go into our parameters. We'll type 0.03 this time. Take a look, and just to see here, compare our first chamfer with our second, so it's 20. And you can see I've gone and moved my little insert arrow back into the first toolpath group. So I want to go ahead and make sure that's down here if I had more toolpaths to work on. So we'll change this to 20 thousandths. Regenerate our dirty toolpath. And again, run through our verify. Right on. So now we've got two matching chamfers. Our part has been machined on both sides, and it's pretty much complete. So this program here is done. The only thing left to do would be to send this to the machine and set up the machine and run the machine. So I hope you learned something here in this demonstration, and we'll see you again for the next one.